Okay, we're still in parametric equations. This time I want to try some stuff that's got some trig functions in it. So if you look at your instructions, your mode and everything still needs to be the same. You still need to be in parametric. You can be in degrees, it's fine. But then when we actually go to graph, it's going to be pretty straightforward. So all I want to do then is kind of talk about what you have to do. Remember, to go from parametric, which is x equals 4 sine theta, sorry, 4 sine t and y equals 5 cosine t, you really want to just get one equation that has x's and y's. Okay, you want to get rid of your trig function, you want to get rid of your t. So what you are going to do is actually pretty straightforward. You're going to just divide both sides of your first equation by a 4. So you're going to get x over 4 equals sine t. And then you do the same thing for the second one, but you divide by 5. So y over 5 equals cosine t. Okay? So here's the thing. Way back, well, not way back, probably what? Beginning of March, maybe end of February, we talked about identities. You verified some identities. And if you have your identity sheet, really the only ones that we're going to be working with in this section are the Pythagorean identities. You have a Pythagorean identity that says sine squared of theta or t plus cosine squared of theta or t, so whatever that actual variable is, equals 1. Well, you have two representations of sine and cosine, right? You have a representation for each one. So basically what you're going to do is sine of t, or, whatever variable, is really x over 4. You're going to square it. Plus, cosine is y over 5. You're going to square that. That has to equal 1. All you did was substitute there. That's it. You took your Pythagorean identity, substituted x over 4 and y over 5. Then you just kind of rewrite it a little nicely. X squared over 16 plus y squared over 25 equals a 1. That is an ellipse. And again, you don't have to memorize or remember all of that. You just kind of hopefully kind of remember that it is an ellipse, and maybe vaguely you remember kind of what we had to do as far as counting things out. We're not going to be concerned with all of your vertices, your co-vertices, your foci. Like, we're not concerned with all that. Okay, what we are concerned with is, can you at least remember where your center is? And if you notice, you're doing x minus nothing and y minus nothing, so your center is actually going to be at 0, 0. And then remember the counting game. Underneath the x squared is 16. So you take the square root of that. You count out 4. You got a point there. You count out 4 to the left. You got a point there. Underneath your y squared, you got a 25. So you count up 5 because you do the square root, and you count down 5 because you do the square root. Okay? And so ultimately you have an ellipse, and this is it. That's all you really need as far as your shape. Okay? You don't need to label which ones are the vertices, which ones are the co-vertices, which one, we're not going to do the foci, so you don't have to do anything about that. Really, you're just looking for the shape. And again, I can't stress enough, you can totally use your calculator. So your mode should be fine. You shouldn't have to mess with your mode. Go to your y equals, type in an x1, you're going to type in, and again, you type in the original stuff. So you type in x1 equals 4 sine theta, not theta, t, so sorry. By the way, guys, your t is the same place your x is the same place your theta is the same place your n is. Okay, and then you do y1 is 5 cosine t. And again, I need you to stop and pause before you actually hit the graph button. Because we have a trig function, because we have sine and cosine, I'm going to want you to hit zoom 6. Okay, now that is going to end up messing up your window from our first example, but again, all you have to do is change your window back if you need to. So zoom 6, and before you do it, make sure that you're ready to watch the direction, because your calculator will graph the direction for you. It starts at some point and then it goes around the ellipse. So zoom 6, okay, and if you look, okay, it's a little bit out of shape. Obviously, our ellipse is more vertical than, horizontal. It's taller than it is wide. So you can also, if you, no, if you want to, no, all right, I'm just playing with the other zooms. It's just going to be misshapen a little bit. But really what you're interested in is graphing so you can find your direction. And if you noticed, it started up at the top, oh, nope, sorry, going the wrong way. And it's heading basically clockwise. Okay, and that is really the only major thing that you need to add. And again, your calculator does that work for you. Okay, and of course, you can go to the table, so do second graph, and you can pull up some numbers. I'm trying to look at, like, for example, again, you're looking at the second and third column. So like you've got at time t equals 0, you have 0, 5, which is basically what we graphed, right? At, I think I have my table set up too bad. No, it's all right. But you can rifle through there and find all those, and you can use your table to graph it. Okay? I'm going to do the hyperbola one next, but I'll do a different video.